Welcome back. Let us go through the question. The casing of a rocket in flight burns up due to friction. At whose expense is that heat energy required for burning obtained? The rocket or the atmosphere? The total energy is given by kinetic energy plus potential energy. Now kinetic energy is given by half mv square and potential energy is given by mgh in this case. The burning of casing results in a reduction in the mass of the rocket. This leads to a lowering in the total energy. Thus, heat required for burning is obtained from the expenses of the rocket. The next question is, comets move around the sun in highly elliptical orbits. The gravitational force on the comet due to the sun is not normal to the comet's velocity in general. Yet the work done by the gravitational force over every complete orbit of the comet is zero. Why? This is because the gravitational force is a conservative force, and we know that the work done by a conservative force in a closed path is always zero. That's why the work done by the gravitational force is zero in a complete orbit revolution. An artificial satellite orbiting the Earth in very thin atmosphere loses its energy gradually due to dissipation against atmospheric resistance, however small. Why then does its speed uh, increase progressively as it comes closer and closer to the Earth? The total energy of artificial satellite remains constant. Thus, when it approaches towards the Earth, the distance between them decreases. This results in a decrease in the potential energy of the satellite. By energy conservation, the kinetic energy of satellite increases, and so does the velocity. Uh, so there is a figure given. The man walks 2 meters carrying a mass of 15 kilogram on his hands. He walks the same distance pulling the rope behind him. The rope goes over a pulley and a mass of 15 kg hangs at the other end. In which case is the work done greater? In the first case, that is in this case, the work done is Fs or Fs cos theta. Now F is given here as mg. So mg is cos theta. Now cos is 90 degree in this case, and eventually it boils down to 0. So the work done in the first case is 0. In the second case, however, the work is given by Fs cos theta as well, but in case of second in the second case, the theta is given by 0 degree. So if we put the values of mgs and cos 0, we get that the work done in the second case is 294 joule. So the work done in second case is greater than the first case.